In this video, I want to talk about evidence of continental drift. And here they are. There's a lot of evidence for continental drift. Number one is the shape of the continents. Okay, as I mentioned before, Alfred Wegener and Francis Bacon thought that they fit together like jigsaw puzzles. And so they fit together like a jigsaw puzzle, different pieces, and they were once all joined together by a massive landmass called Pangaea. That's number one. Number two, fossils. I talked about fossils. Okay, fossils are basically preserved, by definition, preserved evidence of past life, like dinosaurs. Okay, usually found in rock. Okay, and fossils of the same type were actually found in two different continents, as I mentioned, but they seem to have started on a single continent. Okay, and they were taken around the world when the continents split and divided, drifted apart. Okay, so fossils found in different continents. Okay, implies that continents once joined together. Okay, that's number two. Number three, matching rock types. And this is a bit similar to fossils, matching rock types. Okay, now the structure and rock composition of mountains in, let's say, eastern North America can be matched to those of mountains across northwest Europe. Okay, so structure and rock composition of mountains matched across different continents. Okay, for example, as I mentioned, eastern North America and northwest Europe. Okay, so eastern North America, northwest Europe, they matched. Okay. Number three. Number four, there's something called glaciation. Glaciations. Think of glacier. Okay, glacier is a massive lump of ice. Okay, now ancient glaciers, okay, have left valleys. Okay, when they dried up, left valleys and debris across many continents. Okay, including some now. Okay, including some now that are too warm to produce glaciers. Okay, and so continents seem to have moved from colder climates. Okay, to warmer ones. That's what it's saying. Glaciation. Also something called seafloor spreading. Now this is going to be a big chunk of material, but not too bad. I mean, the word says it all. Seafloor spreading. Okay. Now, late 1800s, the scientists who were surveying for looking at undersea. So when they were constructing undersea telegraph cables, okay, remember they didn't have phones back then; they had telegraphs. Okay, they were laying it between North America and Europe. Okay, and they measured. So North America, let's say, is here. Europe is here. So they were laying them between North America and Europe. They measured the ocean depth by actually dropping down very long cables. Okay, dropping long cables to measure the depth of the water. Now, in the middle of the Atlantic Ocean, they actually discovered a large mountain ridge. Okay, the Atlantic Ocean is between Europe and the Americas. A large ridge they discovered, okay, like a mountain ridge, so a massive line with big clumps of mountains. Okay, this extended apparently all the way down as well to the south. So this should be like this. I'm sorry, not like this. Should be like this. Okay, so went all the way to the south. And then in 1925, actually, German scientists actually used sonar. So they had more advanced technology. Sonar uses echoes, right? So bats use it, for example, to navigate. And they confirmed that this ridge actually ran the entire length of the Atlantic Ocean all the way down. Okay, and after 1945, so after just the Second World War, when it finished, further studies using sonar showed that underwater ridges actually were actually found in other oceans around the Earth too, so not just the Atlantic Ocean. And then in 1953, the ridges were found to have a series of cracks, and massive cracks along them, that are called rifts. Rifts is the word you should know. So these are cracks along ridges, the mountain ridges, okay? Cracks in the mountains, like this. running along. Okay, and so hence we come across the Great Global Rift System. Okay, this is where there are rifts running all over the world, all around the world. And then in 1962, an American geologist named Harry Hess, as I mentioned, so Hess, he tried to explain what was happening at these ridges, at the ocean ridges, okay? And he used sonar to map the floor of the Pacific Ocean, and what he discovered was there were flat-topped mountains, okay? So then he proposed that new rocky crust was being formed at the ocean ridges. So proposed that new rocky crust was being formed at the ridges. Okay, and he used sonar to map Pacific Ocean floor. They used echoes. Okay, new rocky crust, and they were spreading outwards. Okay, and he called this seafloor spreading. Okay, these were spreading outwards. Okay, seafloor spreading. That's something you should commit to memory. That was later called seafloor spreading. He didn't call it that. And Hess also proposed that the crust was sinking down right into the earth, forming ocean trenches. So ocean trenches is another word. Okay, the sinking of crust. Okay, think of an actual trench like in the wall. Right, think of throwing something down there, but it basically sinks, right? Sinks down. And the process of crust sinking down, subduction, as I mentioned. Okay, so subduction is the process of crust sinking down. And that is evidence for continental drift.